Everyone, this is Mrs. Lindsay Pereira. Today we're talking about our last topic of the summer bridge course, and it's regarding word problems. Okay, so I'm just going to kind of again jump around, talk about a few key things with this. Again, it's important to kind of realize what words mean certain operations, such as what means addition, what means subtraction, multiplication, division, those types of things. Okay, and again, I'm going to go through a few of these. They're not all the same, but they are similar. There's similar qualities with some of them. And again, we will have some time to answer questions on these as well. So I'm going to start here with number 2, the sum of two consecutive even integers. But before I even get into the rest of the word problem, let's talk about, actually I meant to highlight this, consecutive even integers. Well, if I just pick an even number, let's just say 6, consecutive means the one coming immediately afterwards. So that would be 8, 10, 12. So this is a list of consecutive even integers. But the problem is we don't know what that first number is. So what we do in algebra, we call it a variable. So x is our first even integer. Now let's look at the pattern of these even numbers here. So whatever this starting point is, to get to the next one, hopefully you see that I am adding 2 to that. And then I go from here to get from 8 to 10, I got to add 2 to 8. And that pattern continues. So to get from this very first one, which we don't know what that is, we do know it's x, I have to take the original even integer, the first one, and I have to add 2 to it. So I'm going to have x, and then I'm going to add 2 to that. This, x plus 2, that quantity is our second even integer. So x plus 2 is the, maybe I should use more like arrows there so it doesn't look like a subtraction sign. So that is our consecutive even integer. Okay. So now we got to look at our keywords here. Sum means let's add those two things up. So I'm going to add the first one and the second one. So this is the first one. This is the second one. I'm going to add them because it's a sum. His means equals 26. What are the two numbers? So now we can solve. I'll add together the x's and get 2x. Subtract over the 2. Get 24. Divide. So our first number is 12. And then we have to add 2 to that. Or again, think about it. What's the next consecutive even integer? That would be 14. Okay. All right, so let's take a look at number 3. The ratio of two numbers is 5 to 1. Ratio means a fraction, essentially. Okay, but it doesn't mean that my numbers are 5 to 1. So a lot of times you'll see things written out like this as a ratio. It can also be represented as a fraction. A couple different ways we can write ratios there. Okay, but that doesn't mean the numbers are actually literally 5 and 1. That means they just simply reduce, pardon me, I wrote this last one wrong. That should have been a 1. They just reduce to 5 to 1. So the numbers could have been maybe 10. And, well, let's see, what would that have to be? I had to multiply this one by 2, so I had to multiply that by 2. So 10 over 2. 10 over 2 reduces to our ratio 5 over 1. But again, it can be any multiple of this, and it just simply reduces to 5 to 1. So what we do to represent that is we use 5x and 1x as our two numbers that have this ratio. Now again, we're talking about the sum of these two numbers. So we want to add those up, equals 18. Now we have a nice algebraic equation that we can solve. Get 6x equals 18, divide there. So we get that to be 3. So our first number is going to be 3. And then we plug it in here. So we get 5 times 3. So 15. So our numbers are 15 and 3. And again, we can kind of check through this. If we have the ratio of 15 over 3, yes, that certainly does reduce to that ratio of 5 to 1. Okay. Then we have a couple problems here. Here's another sum of some different numbers here. Area. So again, thinking about area of a rectangle. Some of these I'm just going to give you a few hints on. Hopefully you remember the area of a rectangle in this case is length times width. The perimeter, if any of these talk about perimeter, is adding up all the sides of a figure. So that's something to kind of think about there as well. Okay. Continuing on here. Something like percent. Remember, you're probably going to want to write that as a decimal. So 25%. Remember what that is again as a decimal. And then we have another consecutive integer problem here. This one's odd. And then again, perimeter. Add up all sides of a figure. Okay. So I know I kind of just gave a few hints with some of those, but like I said, some are the same, some are similar, some are a little bit different. But definitely try to do the best you can with these, and hopefully these all look a little bit familiar to you. I'm going to definitely do number 12 and then give you a few more hints here on number 11. So let's take a look here at 12. When I'm doing number 12 here, the cost of a rectangular carpet for a certain room will be $858. Carpeting is sold with whole number dimensions only. Okay, whole number dimensions only. And then it's trimmed to fit the room. The cost is $6 per square foot. What are the dimensions of the carpet? Okay, so I know that again, the carpet is rectangular. So I'm just going to draw a rectangle. And the carpet cost will be $858. So again, this is kind of a cost that I have to think about. I'm going to somehow have to pair these two numbers up together. Okay, so $858 is going to be the total. I'm going to have to figure out, again, $6 per square foot. Well, what is a square foot? What happens is we take all these squares. They don't look like squares, but those should all be squares there. How many of those could I fill up in the room? And I'm just going to call all these dimensions here x. So each square is x by x. Okay, well, let's figure out how many squares fill this up, first of all. So we're going to call that y, number of squares. So I have to take $6 times the number of squares, and that would equal my total cost of $858. Divide that by 6, okay? That's going to be 143. And again, that's the number of squares that I can actually put inside this rectangular piece of carpet. Okay, now here's where it gets a little bit different, right? Okay, so I'm really just going to think about length and width here. Well, this could be a square, but it might not be. And actually, it's probably not, because this is not a perfect square. So I'm really going to think about my length times width has to equal 143. Well, we're very lucky here because there's not a whole lot of numbers that go into 143. 1 times 143. And then if you think about it, 2 doesn't go in there because this isn't even. 3 won't go in there. You got to go a little ways to figure out what actually goes into this number. And what goes into it is 11 times 13. So since we know these have to be whole numbers, that's why we can automatically jump right to this and say that this room is going to be 11, and I believe it was foot. Yep, so 11 feet by 13 feet. So this one was had a little bit of a thought process that we had to put into at the end here, because again, how many squares actually went into this, knowing that it was whole dimensions. Like this couldn't be 10.5 feet or anything like that. It had to be whole numbers. So we really just took 143 and thought about, okay, what are the numbers that are divisible that go into 143, and see what we came up with. And again, because this number is odd, it's not a very unique number, there wasn't a whole lot of multiples that go into that. Okay. All right. And let's just jump right back here to 11 real quick. On 11, it says a student's scores on 5 tests are the following. What must a student score on the 6th test? So the average would be 88%. Now in this case, I'm not going to convert any of these to a decimal. I'm going to leave them as is. But again, let's think about how do we come up with an average. You add up all the numbers, so you do the sum divided by the total number. That equals your average. Well, in order to do this, I want to add all of those tests that I've already taken. But I have to actually add another one in there, and I don't know what I need to get on it. So there's 1, 2, 3, 4, 5, 6. So I divide by the total number of tests, and I want to set it equal to the percent that I'm looking for. Okay. All right. So I just set that one up for you guys. You guys can go ahead and continue and solve that. There is no quizzes for today. It's just literally, again, finishing this, uploading it, and then we have a Google Meet to end our session for the summer. Okay. So again, this concludes our notes on topic 9.